Alright, today we're going to look at section 9.3 from our right triangle trig unit. This is the unit circle, sine and cosine. So the equation of the unit circle is x squared plus y squared equals 1. But I like to start out with the definition of the unit circle. Unit circle, you know, I need that space. A unit circle is a circle with a radius of 1. So we're going to use that to help us develop sine, cosine, and will involve tan, some interesting relationships between them. So if you start with your triangle here in the unit circle, having coordinates 1, 0, 0, 1, negative 1, 0, and 0, negative 1, I hope you would agree then that this is a circle with a radius of 1. So then that means that the hypotenuse of this right triangle would also have to be 1. So this is our point P right here. We talked about theta the other lesson. It just represents an angle. It's a Greek letter from the Greek alphabet. So there's my angle theta, because you want your angles to be in standard position. And so I'm going to call this length x and this length y, because I could refer to this point P as x comma y. And so those are like reference lengths for this little triangle. Now, if I want the sine of theta, we should remember that's an opposite over a hypotenuse. And in our little triangle here, our opposite is y. Okay, and our hypotenuse is 1. So that is going to be y over 1, or just y. The cosine of theta is adjacent over hypotenuse, and that in our problem is x over 1, or just x. So it looks as though this point, x comma y, is really cosine theta comma sine theta, because x is equal to cosine theta and y was equal to sine theta. So now some other relationships come into play. So tangent of theta is an opposite over an adjacent. In our little triangle, that's y over x, which is really sine theta over cosine theta. Important to know those. And if you think about the Pythagorean theorem here, x squared plus y squared should equal 1 squared, which is just 1. So since cosine theta is equal to x, cosine squared and sine theta is equal to y, cosine squared plus sine squared should also equal 1. So that's an important, it's called a trig identity. Okay, so summary, in this unit circle then, sine theta is equal to y. And remember, this is only in the unit circle when the radius is 1. Cosine theta is equal to x. X comma y we replaced with cosine theta comma sine theta. Okay, so let's take a look here. This should make some sense. Number 1 says draw a 20-degree angle in standard position. So, you know, do your best here. There's 20 degrees. Standard position always comes off the right side of the x-axis. So this coordinate right here on the unit circle, if this point, is 1, 0, this is a unit circle, this coordinate would be cosine 20 sine 20. So cosine 20 sine 20, let's go check out what it is. Make sure that you're in degree mode. So cosine 20 is 0.9, we'll go to the nearest hundredth, 0.94, and sine 20 is 0.34, so 0.94 and 0.34. Notice those are values less than 1. They would have to be because the radius length here is 1. Draw a 135 degree angle in standard position, so that angle would be over here. So that angle would be 135. Notice that you could draw another triangle going down over here, and it could be similar, if not identical, to a triangle in quadrant 1. So you could basically transform this triangle that we have into any of the quadrants, and so we'll revisit that in a second. So the cosine of 135 comma the sine of 135 should also be a value less than 1 for both of them, because again we're on the unit circle. So we get negative 0.71 approximately, and sine of 135 is again 0.71. So this should make sense if you're plotting a point. Let's go back here. If you're plotting a point in quadrant 2, you would go left, so it was negative 0.71 comma positive 0.71. So you're going positive, you're going left negative and up positive. So negative 0.71 comma 0.71 makes sense. All right, and they are the same because the cosine and the sine of 45 are the same, which you did in a previous lesson, so this will all tie in eventually. So now we need to look at the signs for sine, cosine, and tangent. So to do that, I'm going to start by talking about these triangles here. In quadrant 1, okay, you could take this triangle on the unit circle, so this could be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And so here's my little right angle. So, this we knew was cosine theta, sine theta. And this was 1. So the coordinate was x, y, but it was also really cosine theta, sine theta. So notice that cosine is positive and sine is positive in quadrant 1. If you took and put a triangle into quadrant 2 that was identical to the triangle from quadrant 1, so we'll try to make that identical height. Okay, so it's exact same triangle. It's just been reflected over the y-axis. Then it should make sense that this distance would be negative cosine theta, and this would still be positive sine theta with a radius of 1. So this coordinate, if we did it with x and y, would have been negative x comma y. But remember, we're saying sine theta is equal to y, cosine theta is equal to x. So this coordinate here would be negative cosine theta comma sine theta. So notice how cosine's negative and sine is positive. Okay, so this is what I'm looking at in the end here. And then if I put a triangle into quadrant 3, identical triangle again. So then that would already have the negative cosine, but then going down it would be negative sine. And that's 1. So now this coordinate would be negative x comma negative y, or negative cosine theta comma negative sine theta. So keep in mind I'm drawing, that might not look it, but they are supposed to be identical triangles, quadrant 1, 2, and 3. So notice the signs are both negative. And then if I draw this, again, identical triangle, but I put it in quadrant 4, then I'd have positive cosine going to the right for the, I'm talking about these points here on the unit circle. The hypotenuse is 1, and it would be negative sine going down. So this point here would be x comma negative y, which would be cosine theta negative sine theta. So notice how cosine's positive and sine is negative. So then what we do is we can then say that cosine and sine are positive in quadrant 1. So here's quadrant 1, 2, 3, and 4. And this is quadrant 1, 2, 3, and 4. I'm going to put some stuff inside there. So for quadrant 1, they were all positive. Now we need to set up something to do with tangent here. Okay? If you look, tangent was equal to sine divided by cosine, or y divided by x. So tangent would be positive sine divided by positive cosine. So in quadrant 1, tangent would be positive. Okay, so tan would be positive. In quadrant 2, tan would be a positive sine over a negative cos. So tan would be negative. In quadrant 3, tan would be a negative sine over a negative cos, and a negative divided by a negative is positive. And in quadrant 4, tan would be a negative sine divided by a positive cos. Just doing, it would be the opposite over the adjacent, and we would be referring to these angles right here if you were looking at the opposites over the adjacents, those angles that are coming off the x-axis down to the terminal side. So if we look at quadrant 4, tangent's going to be negative. And so now we can kind of generalize here and say, in quadrant 1, they're all positive. So cosine, sine, and tan are all positive. In quadrant 2, we could say cosine was negative, sine is positive, and tan is negative. In quadrant 3, we could look at our signs and say cosine is negative, sine is negative, but tan's positive. And in quadrant 4, we can look and say cosine is positive, sine is negative, and tan is negative. So they kind of have, in quadrant 1, they're all positive, but in quadrant 2, sine's the only thing that's positive. In quadrant 3, tan's the only thing that's positive, and in quadrant 4, cosine is the only one that's positive. So to bring this all together, we say all sine, tan, and cosine. That stands for where they're positive. So this stands for sine is positive, tan is positive, and cosine positive. And this is all of them are positive. So we have like a little rhyme. All students take chemistry. You could ask your teacher tomorrow for some others as well. But those you need to remember. All right, so then if we look at the, we've got this big circle here. If we look back at our chart from the other day, I'm going to go forward here and just review that. I have sine, cosine, and tan of 30, 45, 60. I need that now. There was a chart. If you look back at it, there was a little shortcut. Sine, it was 4 over 8 equals 1/2. This little shortcut, you go, this was radical 2 over 2 and radical 3 over 2, and then it went radical 3 over 2 for cos 30, cos 45, radical 2 over 2. Here's the shortcut, though. You go 1, 2, 3, 3, 2, 1. 2's on the bottoms. All of them have a 2 on the bottom, and square root the tops. Now, if you square root 1, it's just equal to 1. But you could do that if you want. You could say square root 1. I'm just going to leave it as 1. And then we just learned that tan is equal to sine divided by cosine, right? So if you take 1/2 divided by radical 3 over 2, the 2's will end up dividing out, and you end up with 1 over radical 3, and when you rationalize that, that's radical 3 over 3. And then for tan of 45, that's just going to equal 1, because if you divide it by itself, you'd get 1, and tan of 60 would be radical 3. The 2's again would cancel out. So now, I'm going to use this to help me back on my chart. Okay, so here is 1, 0, 0, 1, -1, 0, and 0, -1. So now I can figure out the sine and the cosine of all of these. I'm just going to go CS, 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 and CS. These stand for cosine and sine. You're on the unit circle, so the cosine of 0 degrees is 1. The sine of 0 degrees is 0. And you could verify those on your calculator. Cosine of 0 is indeed 1, and the sine of 0 is indeed 0. So now I'll just go around here, and so 0, 1, so this is going to be 1, 0. -1, 0, so 0, -1, because you have to kind of go backwards. I put sine first, and then -1, 0. And 360 is coterminal to 0, so they're the same. Now, tangent is just y over x, or you could say that it's sine over cosine. All right, so 0 over 1 here. 0 over 1 is 0. 1 over 0 is undefined. 0 over -1 is 0. -1 over 0 is undefined. And 0 over 1 is 0. I'm just using, I'm using the values right above them. So now when I get to this little chart here, I know that the cosine of 30 that I just found from the previous page is equal to radical 3 over 2. So we could say that this coordinate is radical 3 over 2, and the sine of 30 was 1/2. And for 45, I knew that was radical 2 over 2 for both sine and cosine of 45. And for 60, the cosine of 60 was 1/2, and the sine of 60 was radical 3 over 2. But imagine these are identical triangles in the other quadrants. So an angle of 120 would have the same value as an angle of 60, except the first coordinate would be negative. So this coordinate would be negative 1/2 comma radical 3 over 2, the same as the 60. The 135 and the 45 would be the same exact triangle. So it would be negative radical 2 over 2, radical 2 over 2. 150 would have the same exact triangle as 30. It would be negative radical 3 over 2 comma 1/2. So we can get all sorts of points here. 225, I'm sorry, this would be 210, so this is off a little bit. That's not supposed to be up there. That would be the same as 30, except both coordinates are negative, so it's negative radical 3 over 2, negative 1/2. Negative radical 2 over 2, negative radical 2 over 2 for 225. Which is the same as 45, and 240 would be the same triangle as 60, except both negative. So negative 1/2, negative radical 3 over 2. 300 is the same, if we follow it along, as 120. So that's going to be positive 1/2, negative radical 3 over 2. 315 would be positive radical 2 over 2. Negative radical 2 over 2, and 330 would be the same as 150 or 30. Just first one's positive radical 3 over 2 comma negative 1/2. And we're going to see those again in our notes. Okay, so a couple examples here to finish up. The terminal side of angle ROP in standard position intersects the unit circle at P. If the measure of angle ROP is theta, find sine theta, cosine theta, the quadrant, and the measure of angle ROP. So let's find this point. So we're on the unit circle, so this is 1 comma 0. So we're going to go over 5, radical 5 over 5, down negative 2 radical 5, 5. So I'm going to go over and down. So I'm on the unit circle, so this point, radical 5 over 5 comma negative 2 radical 5 over 5, okay, is going to help me represent my sine and my cosine, because this is a hypotenuse of 1, and this side is radical 5 over 5, and this side is negative 2 radical 5 over 5. Here's my little angle theta. Now, angle ROP is actually this angle here. That's angle ROP. Okay, but that angle ROP I can reference by using these triangles. So, I am interested in the sine of this angle. This little angle here will reference this big one in blue. And so the sine we know is the y coordinate, and the cosine is the x coordinate. And even if you set this up, sine theta is going to be opposite over hypotenuse. The opposite is negative 2 radical 5 over 1. So that's the answer for sine theta. Notice it's also just the y coordinate. Cosine theta equals x. That's going to be just radical 5 over 5, or you could do an adjacent in the triangle over a hypotenuse. And the hypotenuse is 1, so you'd get radical 5 over 5. So you basically, when you're given this kind of question, they're kind of just seeing that, do you know that the y coordinate represents sine theta and the x coordinate cosine? So I'm in quadrant 4, use Roman numerals to represent those. And to do theta, we would need our calculator. So I'm going to do second cos of the square root of 5. So we need to end that. Oops, I need to end that correctly. There we go. No, I think I'm good. I don't need that divided by 5. I just can't have that radical extending over the divide sign. Okay, so there we go, second cos. So there's my angle, 63.43. This might be, I'm going to go with 63.43. So that little theta measure in there is 63.43 degrees. Now the measure of angle ROP is equal to 360 minus 63.43. So that's 296.57. Okay, next one. We are in quadrant 2. I'm going to go over and up. So this should be negative 9 over 41, and this should be 40 over 41. And if I bring that back, that's a radius of 1 because we are on the unit circle. So if we just kind of think about sine theta is equal to y, well, our y coordinate is 40 over 41. Our cosine theta is equal to x. That was negative 9 over 41. If you want to do opposite over hypotenuse, it will also work. The quadrant we're in is quadrant 2 in Roman numerals. And now here's theta. Okay, but this now is angle ROP. Okay, so here's really R. Here this is O, and this was P. So to find that theta, I'm going to do second sine 40 over 41. So second sine 40 divided by 41, which is what we did before. So 77.32. And if I want to know the measure of angle ROP, I should just be able to do 180 minus 77.32. So 102.68. Okay. Now, next, for each of the following function values, find theta if it's between 0 and 360. So sine theta equals 0 and cosine theta equals negative 1. So I am envisioning my unit circle, and I'm envisioning that this is the x-coordinate and that's the y-coordinate. So where is it that it's negative 1 comma 0? Because that would be the x-coordinate. So negative 1 comma 0 would be right here. And that, we need it to be between 0 and 360, so it's got to be 180. Can't be negative 180. And then here I'm looking, all right, again, here's x, here's y. So where is 0 comma 1? Well, if I plot up here, here's 0 comma 1, and that's 90 degrees. So those are the answers for that. For C, for each of the given angle and standard position, determine to the nearest hundredth the coordinates of the point where the terminal side intersects the unit circle. Well, for that, you would just go draw your angle of 137. So all we have to do here to find this coordinate is do the cosine of 137 comma sine of 137. So to our calculator, I'm just going to punch that in, and I'm going to tell you the coordinate is going to be negative 0.73 comma 0.68 to the nearest hundredth. Negative 45 would be here is my angle of negative. So here's 137. Here's negative 45. So again, I'd be looking for cosine of negative 45, comma, sine of negative 45. And when you plug that into your calculator, you would get negative 0.71, negative 0.71. You don't have to put a negative in front of the sign because it's all going to take care of itself here. And then 200 would be here. And so I'd be looking for the cosine of 200, the sine of 200, which is negative 0.94, comma, negative negative 0.34. And that is that.